Hi, this is Dr. Kingston, and in this video we'll be talking about the dermis. Our objectives here are to identify the two layers of the dermis and to describe their composition. While we're doing that, we will be talking about the neurovasculature that serves this region and talking about how it is able to not only supply the dermis but also the epidermis. And then we'll finish up by talking about the accessory structures that are rooted in the dermis. To quickly review for you here, when we're talking about the integument, we're talking about our three layers. From superficial to deep, we have the epidermis, dermis, and hypodermis. We'll be focusing on the dermis here, which is made up of a dense, irregular connective tissue. The cells here, unlike much of the epidermis, are live, and they are well vascularized. The dermis has regulatory, protective, and sensory functions. It's going to function with thermoregulation, controlling the body temperature. It has some to do with excretion and absorption, mostly because our sweat glands are anchored here. In terms of protection, it is backing up the epidermis against abrasion, friction, and infection. And in terms of sensory perception, this is where the majority of our tactile receptors are located, as well as our temperature receptors. In terms of structure, the dermis is a dense, irregular connective tissue. So what that means is that it is going to be kind of a gel matrix suspended by collagen and elastin fibers. These are going to protect deeper structures, and they're going to be a foundation for the accessory structures of the integument, so hair, nails, those kind of things. That means that this area is able to be highly vascularized. So remember, it's not just supplying itself, it's also going to be supplying nutrients up to the epidermis. All right, so we can see here in our illustration, we've got collagen and elastin fibers here. Okay, that's going to be supporting our cellular matrix, and within that matrix then we have a number of fibroblasts, which are the cells that make the collagen and elastin fibers. Okay, they look kind of like this. And then we have a number of immune cells, just like we saw up in the epidermis. Okay, we have a larger variety here, but I'm not going to make you memorize what all of them are. It's enough to know that we have them and they're hanging out here. The dermis can be separated into two regions, and these are largely by appearance. Okay, so superficially touching the dermis, we have the papillary region. And if you look at this region here, you'll notice in this slide that the fibers that you can see here are very small, fine, and they're arranged very irregularly. Okay, this is called the papillary layer because you have these little papillas. Now remember, papilla means nipple. So they look like nipples sticking up into the epidermis, okay? So they're protruding superficially that way. The reticular region is a little bit different. That's this area down here where we can see these fibers are much thicker. And when we really look at them, we see that a lot of them are traveling in the same direction, okay? Reticular means net-like. So it's named for its appearance, just like papillary layer is named for its appearance too. So what we have here, the reason this is called net-like, so you see we've got a whole bunch of these traveling parallel, and then we'll get some crossing each other like that. So it makes a net-like structure. It's good for support. All right, let's talk a little bit more detail about each of these then. The papillary region, again up here, whoop, its purpose really is to increase contact area with the epidermis. So see that line I just drew across there? That is a much longer line than if I were to draw a straight line like so, right? This helps to strengthen the integument. When you have more contact between cells like this, you have tighter junctions, okay? This is also better for vascular communication. So you can have diffusion going on at all of these different points here. So it makes it much easier for nutrients to diffuse into that avascular epidermis. Okay. Um, the papillae then are really what allow both of these things to happen, all right? So as I was saying, they project up toward the dermis, but they are variable in their size and shape across different regions. They tend to be much taller and more densely packed in skin that is highly sensitive. So again, the same places we see thick skin, right? So palms and soles, and around the lips and genitalia. These also tend to be areas with more mechanical stress. All right, so we're putting shear forces on our skin, and having this arrangement helps to avoid the epidermis being pulled away from the dermis. But arguably one of the most important things that they do is going to be to provide a pathway for the neurovasculature to approach the epidermis. So let's take a look at that here. Within these little papilla, we have a couple things going on. So let's start talking about the vasculature first. What we have is large blood vessels coming up from the hypodermis here into the dermis and branching. And then within these papilla is where we find a number of capillary loops. So here's one, here's some here. And it's really these capillary loops that are pushing different nutrients up into the epidermis there. Okay, so that is our pathway for blood, those capillary loops. We also have some sensory structures here too, and specifically we have some cells called Meissner corpuscles. So here is their name over here, and this is one here. I'm just going to trace right over it, make it a little bit bigger and easier to see. So these are encapsulated nerve endings, and they detect movement or vibrations happening in the skin. Okay, so vibration comes in here, it hits this little capsule, that depolarizes and sends its message down to big mama nerve down in the hypodermis. Okay, these are good for sensing texture. So if you were to run your fingertips over paper or sandpaper, something like that, these are what pick up the vibrations from the movement of your fingertips and tell you that way what the texture of what you're touching is. All right. One thing we're going to take a little bit of a detour to talk about here, because they're related to this papillary layer, are dermatoglyphics. And dermatoglyphics are fingerprints, so patterns formed by your epidermal ridges. All right, these are very characteristically either in arches, loops, or whorls, and they are unique to individuals. And the reason that they're unique to individuals is because they develop along with you in utero. So as you are growing in utero, the finger pads, so that fat pad on the end of your finger, will grow and swell at different rates. And depending upon which part of it is swelling and which direction it's swelling in, you develop ridges that follow that. Okay, so everyone's a little bit different, and these don't change then after this initial development. So you'll have the same set of fingerprints your whole lives. But Dr. Kingston, this has to do with the epidermal ridges. We're talking about the dermis. The dermal papillae actually play a large role in these ridges. So let's take a look here. Those dermal papillae are going to mirror the epidermal ridges. So if we look in the image over here, the blue one, we've got our epidermis here, right? And then we've got our dermis down here. Okay, and we can see that these ridges, they're not perfect, but they really do mirror what's going on in the epidermis. Now, this functions to, number one, as I was saying on the last slide there, form a really tight bond between the epidermis and dermis, just because you have so much of them touching each other. All right, it's like the gyri in the brain. When we can fold up a piece of paper, we end up with a lot more surface area contact. Same thing's going on here. The other thing is these epidermal ridges here are also expanding the contact area that's possible between your fingertips or the soles of your feet, palms of your hands, and whatever they're contacting. For pliable surfaces, surface area is very important in determining how much friction you can generate. So if you are walking, with bare feet, or if you're climbing using just hands and feet, not claws like primates do, these become very important in increasing surface area for you. Okay, the other thing that they do is enhance tactile sensation, and they do that specifically with those Meissner corpuscles that I pointed out to you. So if we look at the bottom image here, here's your Meissner corpuscle. Isn't he pretty? And you will notice that there are papillae on either side of him, and you've got these ridges coming down from the epidermis on either side. So if you apply pressure here from the epidermis on down, this lever will compress the Meissner corpuscle and it helps it to activate. Okay, so we've got a tight bond, we've got friction enhancement, and we've got magnifiers for the Meissner corpuscles as functions here for the dermatoglyphics. All right, so coming down out of the papillary region then into the reticular region. Again, reticular means net-like, and that is referring to how those collagen and elastin fibers are arranged on top of each other. So we've got them running parallel in groups and then intersecting at various angles like that. Okay, we have thick collagen and elastin fibers down here, very coarse, and we want to have big coarse fibers down here because this is where our accessory structures are rooted for the most part. So hair, nails, glands, these are all kind of finding a home by burrowing out a little space in the reticular region. The other thing that having these collagen and elastin fibers that run parallel for a lot of their existence do is create tension lines in the skin. And these are variable by regions of the body, and they have a pretty strong clinical correlation here too. So these tension lines are also called Langer lines. They change depending upon the region of the skin. So you can see here on the illustration different things that can change their direction. Like bony projections, you can see them changing at the hips here. Muscle orientation, you can definitely see, your abdominal obliques in here. And you can see that they change around mobile joints as well. Okay, why would you even care about this? Well, if you're planning to go into healthcare and you are doing anything that involves incision and suturing, you want to make your incisions parallel to your tension lines. Okay, so you would want to cut like that or like that because that will heal more cleanly. Okay, if you were to make a incision that is perpendicular to those, it will pull apart while it's healing. Okay, so it will create more scar tissue around the site of healing. All right, those accessory structures that I was talking about that have their root here down in the reticular layer. One of these we've started talking about very briefly, and that's the pilosebaceous apparatus. And that refers to hair and the follicle that it grows in. Okay, so you can see here, our hair starts out here, travels through the epidermis, and it's actually formed from epidermal cells that are making a little pocket here down into the dermis, like so. So that's the follicle. And then those reticular fibers provide mechanical support for that follicle and shaft. Then you've got your erector pili muscle here that can make it stand up, and sebaceous oil gland there. The other thing that we've got going on here are our sweat glands. Oops, that's not what I meant to do. Let's go back. And we can see one of those here, and those are going to be rooted pretty much entirely in the reticular layer of the dermis here. All right, so we talked a little bit about those capillary loops feeding the epidermis, but they also play a very important regulatory role, specifically in thermoregulation. So the capillary loops themselves behave very much like normal blood vessels, wherein they can constrict or they can dilate. Okay, so dilate's going to allow more blood to flow through, constriction will allow less. These are specifically going to respond to changes in temperature. All right, so when the body is cold, they will constrict and allow less blood to flow through them. That means less blood is coming up toward the surface of the skin, so more body heat is retained. They're going to do the opposite when the skin is warm. So when it's warm, they will dilate to allow more blood up, and that allows blood to be lost via radiation and convection currents. All right, so we're coming up on the end here. So here's your practice question. What type of nerve endings are found in the dermal papillae? All right, those are the Meissner corpuscles. And remember, those are kind of wedged in between your, so here's a papilla. You've got Meissner corpuscle here. There's our nerve. And then we've got this bit of epidermis that comes down in between our papilla. So when force is pushed through that bit of epidermis, that activates the Meissner corpuscle. All right, and that actually is the end. I will see you in the next video.